Today is the composite pattern, also known as the object tree. Here is the fundamental question. How do you treat a single item and a complex group of items exactly the same way in your code? Think about files and folders. A folder can contain files, but it can also contain other folders. When you ask for the size, you don't care if it is a single file or a deeply nested folder tree. You just want a number. Or imagine an e-commerce system where an order contains simple products and specialized shipping boxes. A box can contain products or even smaller boxes. We need the total price of the entire order, no matter the nesting. You need to calculate the total price of the entire order, no matter how deeply things are nested. Without a pattern, your code becomes a mess of type checking and manual recursion. You check if it is a product, then you check if it is a box. If it is a box, you start another loop. And what if that box contains another box? You call the function again. It works, but it is extremely fragile. Every time you add a new type, like gift wraps or bundles, you have to update these conditionals everywhere. The composite pattern solves this by defining a common interface for both individual items and containers. The leaf is the basic building block. It has no children and performs the work itself. The composite is the container. It stores children and delegates the work to them recursively. Because they share the interface, the client code treats them exactly the same. It is seamless. Think of an army. A general gives an order to a division. The division passes it to its brigades. Brigades pass it to platoons and platoons to soldiers. The general doesn't talk to every soldier. The structure itself handles the delegation. That is the essence of the composite pattern. Let's implement it in TypeScript. First, our common interface, order item. Now the product class. This is our leaf node. It holds a name and a simple price. The getPrice method is straightforward. It just returns the product's individual price. The box class is our composite. It manages a collection of order item objects. It includes methods to add or remove items from its internal list of children. Here is the magic. Its getPrice method sums the results of getPrice from all its children. If a child is a box, it triggers its own internal sum. The recursion happens via polymorphism. Let's put it to use. We create a few products like a phone, a case, and a charger. We group the accessories into an accessory box. Note that this box is also an order item. Now we create a phone bundle and add both the phone and the accessory box to it. One call to order, getPrice handles the entire nested tree and returns the total. This tree can be 10, 50, or 100 levels deep. The client code never needs to change. One simple call at the root of the tree traverses every single node and returns the result. The main benefit is flexibility. You can add new types of items without breaking existing code. It simplifies your client code significantly by removing complex conditional logic. The downside? It can be too general. It is harder to restrict what can be added to a composite. If you need strict rules about which components can go together, the composite might be too loose. When refactoring, look for is-a and has-a relationships that form a tree structure. Replace those manual loops and type checks with a shared interface method. Your future self will thank you. In the real world, this is how modern UI frameworks like React and Vue work. A page is a composite of components which might contain other components or leaf elements like buttons. The framework calls render on the root, and the entire tree renders itself automatically. Graphic engines use this for scene graphs. A group node moves and everything inside it moves too. From a 3D character's skeletal structure to the foliage in the background, it's all composites. Compilers use this pattern for abstract syntax trees to represent the structure of your code. Evaluating an expression becomes a simple tree traversal. The pattern is truly everywhere. How does it differ from other patterns? While decorator adds behavior, composite builds structure. Use composite when you want to represent part-whole hierarchies. Use decorator to extend functionality. The key takeaway for the composite pattern is prioritizing uniformity over specificity. By treating groups and individuals the same, you create systems that are easier to scale and maintain. Here's a challenge for you. Try building a nested menu system using this pattern today. Think about how menu and menu item would share a common interface. It's great practice. We've covered the concept, the implementation, and the real-world applications of this powerful pattern. Mastering the object tree will make you a much more effective software architect. That's the composite. Trees made simple. I hope you've enjoyed this deep dive. Next, the decorator, which adds behaviors layer by layer. See you in the next episode.